All right, the first thing that we're going to talk about with trig is something that you actually learned a long time ago, and that is the Pythagorean Theorem. But before I just write it out with letters and math operations, I want to kind of talk to you about what Pythagoras thought about his Pythagorean Theorem. Because whenever he did math, he only did math with geometry, only with shapes. He didn't have algebra where he used things like a squared and b squared. That's just how we talk about his theorem. The way he saw it was this. You've got a right triangle, and there are three sides. We've got two sides here, which he called the legs. And these are the legs because they are not what our third side is. The third side is our hypotenuse. The hypotenuse is always the side that is across from our 90-degree angle. So Pythagoras realized that there was a relationship between these legs and the hypotenuse. And that relationship held no matter what size the triangle was, as long as one of the angles in the triangle was a right angle, was 90 degrees. So his idea about this held for any right triangle. And what he said was that the square of the two legs added together is equal to the square of the hypotenuse. So the way that we think about this nowadays is a squared plus b squared equals c squared. But that's not really what he meant. When you say square, before you even learn about this 2 here, which means squared, even back in kindergarten, what we think of when we think of square is something that's got four sides, and the four sides are equal. Well, that's actually the same square that Pythagoras was talking about when he said that the square of the legs added together is equal to the square of the hypotenuse. What he meant was, if you take and draw a square that has side length equal to the two legs, you get two squares here. We're also going to take and draw a square on the hypotenuse. Yeah, it's a little bit out of scale, but it works. Okay, so draw a square up here. Now, what he was saying was that if you take this square and you cut it out, and you could rearrange it and cut this square out and rearrange it, you could make it so that it fit into this square perfectly. Basically, the area of this square plus the area of this square is equal to the area of this square. It's kind of interesting that our terminology came up, a number times a number gives us square, and our shape with four sides that are the same is called a square. And that's because if we get the area of this, we multiply this times this, which is squaring the side in order to get the area inside of it. So geometrically, we've got the area of this square plus the area of this square is equal to the area of this square. But normally we don't draw all the squares out whenever we want to figure this out. We just write it down algebraically with some letters and numbers. So we get a squared plus b squared equals c squared. So now we know that what the Pythagorean theorem actually means. Let's take a look at how it can be used mathematically. If we've got a right triangle, which just means that any triangle with one 90-degree angle in it, both of these angles will always be less than 90 degrees, so they are acute angles. So what we can do is we can use our Pythagorean theorem, or algebraically, a squared plus b squared equals c squared, to find a missing side. It doesn't have to be the hypotenuse. In this example, it just happens to be. We could also find a missing leg if we happen to be missing one of those and we had the hypotenuse. But let's take a look at this problem. So let's say we've got that one leg of our right triangle has a length of 6, and the other leg has a length of 12. And I want to know what is the length of the hypotenuse of the triangle. Well, all I have to do is decide which of these is going to be A, which is going to be B, and which is going to be C. So one nice thing about A and B here is that it really doesn't matter which of these two legs I choose, as long as A and B are both the legs and not the hypotenuse. So I'm going to say that this is A and this is B. That leaves me with the hypotenuse always being C, and that's true. it doesn't matter which side you are looking for, the hypotenuse is always C. So what we're going to do is fill these numbers in, 6 for A, 12 for B, and figure out what we get for C. So we've got 6 squared plus 12 squared equals C squared. So we can just do a little bit of algebra over here. 36 plus 144 equals C squared. And if we do that, then we are going to get 36 plus 144 is equal to 180. And that is equal to C squared. So 180 equals C squared. Now we need to figure out what just C is, because remember, the side length is C, not C squared. So to find out what C is, we need to cancel out the square root, and the opposite of, need to cancel out the square. The opposite of squaring something is taking the square root. So let's do that on both sides. And we're going to get 6 times the square root of 5 is equal to C. I know that looks like a weird number, but it is a length. And while this is a radical, and so it's more exact than if we had a decimal form of this same answer, we could get this in decimal and round it, which is what you would do if, say, you were trying to measure the length. You know, with an actual ruler, you're going to be using decimals. So it's okay if, if you round this to a decimal, unless it says to be exact. If it says to be exact, then leave your square root sign in there. And that's how Pythagorean theorem can help us to find a missing side. Like I said before, it doesn't matter which side you're missing. You can be missing a leg, or you can be missing the hypotenuse. As long as you know 2 sides of the right triangle, you can always figure out the third side using the Pythagorean theorem.